Hello, everybody, and welcome back. We're going to be starting the questions in Part C. These are the typically challenging questions. Not to say that questions 19 and 20 can't be challenging, but usually this is where the difficulty jumps up a little bit, culminating in what are usually the hardest questions, 24 and 25. 25 is supposed to be the hardest one, but, I mean, if you're not someone who's good with spheres, 24 might be hard, but we'll get to that. Right now, we're dealing with question 21. On our 2010 Fermat paper. If x minus y divided by z minus y is negative 10, then the value of x minus z over y minus z is. Okay. So I've got three unknowns and one equation. I'm not going to be able to solve what x, y, and z are. Now, I think there's probably a couple ways we could go about doing this question. The one way is to sort of technically satisfy all the conditions. So pick numbers that make this work. So for example, if I let x be negative 9 and y equal 1 and z equal 2, then I'm going to get negative 9 minus 1 over 2 minus 1, which is negative 10 over 1, which is negative 10. So this x, y, and z do technically satisfy my conditions. Okay? They are a solution. And so plug them in and see what I get. So we get x minus z, so that'd be negative 9 minus 2, over 1 minus 2, and you'll get negative 11 over negative 1, so the answer is 11. So it should be A. Now that's a fine way to do things, but you have to be careful, and you have to be sort of logically aware of how the question is put together. They are giving me an equation or a series of equations, or sometimes this appears sort of as a geometric setup. I'll talk about that in a moment. But they're giving me an equation, and it's got x, y, and z, and they're related. All I know is that they are equal to negative 10. Okay? And then they're asking me for a definitive answer. This is the value of. Now, when they make these contests, like this might not work for some contests that's very poorly made, but they tend to make these contests very well. Okay, there's a lot of review process, a lot of people look at these things. And so if they are saying, well, here are three things that are loosely related, figure out the value of these three things related in some other way, you can bet there is going to just be the one answer for a multiple choice contest. Because if 11 were an answer and negative 9 were an answer, they'd have a lot of problems on their hands when it comes to marking this. They'd have to give out 8 free marks, basically. And they don't want to do that. So they make sure they know what they're talking about. Okay, so with that in mind, like this wouldn't work on a written contest because you'd have to explain your reasoning. There could be multiple answers. You'd have to prove that there aren't multiple different answers and things like that, which is what we're going to do. We're going to do this algebraically in a little while. But you can exploit the fact that there is guaranteed one answer. So if I can just get an x, y, and a z that satisfy all the preconditions, plug them into the formula, I will get the answer, whatever answer they want me to get. The point is, the way the question is set up, any x, y, and z that satisfy the first expression will get the same value for the second expression. And this can appear in lots of other ways. As I mentioned, you can get this with geometry questions when they say things like, a quadrilateral has its diagonal and does this, then there's this angle here. And if it helps to simplify things and assume that that quadrilateral is a rectangle or a square, you can actually simplify things in that way, provided that drawing a square doesn't change any of the diagonal properties or angle properties. If you can get a shape, a quadrilateral, however special you want, that satisfies those conditions, then you're allowed to work with that. But it's got to satisfy all the conditions they give you, and then you make your conclusion. You can't just be, it says quadrilateral, I'll just assume it's a square. It doesn't work like that. If it says quadrilateral and it's got this, this, and this, and you go ahead and say, well, I wonder if I could get a square that does this and simplify my work. And you can get a square whose diagonals intersect at this point and that makes an angle of 30 degrees at whatever. If you can get a square that does that, then that's okay. Okay? It's a harder thing to master, but it certainly simplifies things for this question. I just found an x, y, and a z that worked. That said, the explanation has kind of been rambling. But let's get back to how you would do it if you weren't that accustomed to things like this. Okay, what would I actually do if I didn't just pick out an x, y, and a z and said, I chose them so it worked, so it's going to work? Well, we're going to have to rearrange some algebra here. So x minus y, z minus y, and that's equal to negative 10. And then we want x minus z, and then, is it y minus z? I feel like it's y minus z. Yeah, y minus z. So that's the goal. Now notice that we've got a z minus y here. So I could say something like x minus y over y minus z. I'm just multiplying this by negative 1, and I get 10. Right? To see that, just off to the side, let's note z minus y is negative 1 times y minus z. Or you could say y minus z is negative 1 times z minus y. Okay, so all I'm doing is replacing this and then canceling out the minus sign up here with the minus sign that you would get out here. Okay, so okay, we've got y minus z. Now I've got the denominator that I want. I've got x minus y, but I need x minus z, and therein lies the problem. So how can I get x minus z? I need to get rid of this y and subtract off a z. So I could add a y and subtract a z from the top. Well, that would be great. But how can I mean, that would work. This is the same expression as the one I want. But how does that relate to the 10 that I just calculated? Well, we can separate it out. Now, I just explained that this part is 10, and this is something over itself, so it's always going to be 1. And that's how we can see the answer is going to be 11. And this is, in some sense, a more exact, more complete picture, because this technique, this manipulation, would work even on a written contest. Okay? And it didn't take that much longer. Sure, you can play around with it a little bit, and it might be hard to spot that you need to rearrange the denominator first. And there might be another way to do it without rearranging the denominator first, certainly. But I would say it's a fairly straightforward algebra question. It's just a little scary because there's 3 unknowns. Okay, and that, I believe the answer there was A. So that finishes off question 21. Up next, question 22. I'll see you for that next time.